Welcome to Next Minds Academy series of lessons. My name is Ronald and I'm your tutor. So we are going to start on A-level physics. Remember to subscribe to our channel, Mr. Academia. Just press this button here and you subscribe, share our lessons, like our lessons, comment. You can also visit us at our website at www.nextmindsacademy.com. Of course, learning starts here and it's always move on with us. Share, subscribe, and like all our lessons. So we are going to start by looking at waves in our A-level series. So we shall look at waves and wave motion. So if you are to define a wave, the wave is defined as a disturbance from equilibrium position, which travels with time from one region to another. So of course the word equilibrium here and the word disturbance, when traveling with time from one region to another, are the keywords in the definition of the wave. So we know the meaning of equilibrium, that is balanced position, is what we may call equilibrium, or a position whereby a body is balanced. So any disturbance of a body from the equilibrium position that travels with time from one region to another is what we refer to as a wave. So when a wave is moving, it transfers energy. Energy is transferred as the wave moves from one point to another between the points. So waves can be classified into two. There is what we call the electromagnetic waves and what we call the mechanical waves. So if you are to look at electromagnetic waves, these are the ones that are produced by disturbances of a material and are transmitted by particles of the medium oscillating to and fro. They are transmitted by particles of the medium. So meaning that mechanical waves always require a material medium for their transmission. So they can be felt and seen, but the most important thing that we should know about these types of waves is that they require a material medium to be transmitted. So some of the examples of mechanical waves, we have sound waves, they are mechanical, water waves are mechanical, waves in compressed springs and waves in stretched strings. All these ones here, they require a material medium to be transmitted. So if you look at the other classification of waves, what we call electromagnetic waves, so these ones are basically produced by disturbances which basically vary electric and magnetic fields. So varying electric and magnetic fields, disturbances which vary that, produce what we call electromagnetic waves. And for them, they do not require a material medium to be transmitted, meaning that they can travel through a vacuum since they don't require a material medium for their transmission. So examples of electromagnetic waves, we have light waves, we have gamma rays, we have radio waves, and all other waves in the electromagnetic spectrum, or all other electroband waves. So all electromagnetic waves, they travel at the speed of light, which is 3 exponent 8 meters per second. So among the properties of electromagnetic waves, they can travel in a vacuum, meaning that they don't require a material medium for their transmission. Then they travel at a speed of light. This is supposed to be 3 times 10 exponent 8 meters per second. They are made by varying electric and magnetic field, or you can say they are produced by varying electric and magnetic fields. Then they vibrate with a high frequency and they have no charge. So basically, this is the electromagnetic spectrum, and increasing wavelength, that is wavelength, increases from this side to that side. So that means that the frequency is increasing in this direction. So in this direction, we have what we call the frequency is increasing in that direction, whereas the wavelength is increasing in this direction. So this means that radio waves have the highest wavelength and they also have the least frequency, whereas the gamma rays here, they have the highest frequency and the least wavelength. So if you look at the differences between mechanical and electromagnetic waves, for mechanical waves, they need a material medium to be transmitted, whereas electromagnetic waves, they do not require a material medium, meaning that they can travel through a vacuum. Then mechanical waves, they are propagated or they move at relatively low speeds. These ones, the electromagnetic ones, they move at higher speeds. That is, the speed of light is too high. Then they are due to vibration of particles in the transmitting medium, whereas the electromagnetic waves, they are caused by disturbances of the magnetic and electric fields. These ones have a longer wavelength, whereas electromagnetic waves have a shorter wavelength. So if you look at the types of waves, we have what we call the transverse waves, and we also have the longitudinal waves under the category of the types of waves. So the transverse waves, these are the waves in which the displacement of the particles in the medium is perpendicular to the direction of the wave. The displacement of the particles perpendicular to the direction of the wave travel. So in that case, we shall have waves which are traveling like this. Waves which travel like this are referred to as transverse waves. So you find the particles are vibrating in this direction, or they are vibrating in this direction, whereas it is traveling in this direction. So you can see that there is some perpendicular property or component there between the direction of vibration and the direction of wave travel. So transverse waves are characterized by what we call crests and troughs. So for example, this one here is a crest, whereas this one here is a trough. So a trough is a part which is below the wave, is part of the wave below. You can see this is the trough, and then the crest is the part of the wave above the line of zero disturbance. So this line here is the line of zero disturbance where the wave is said to be in equilibrium. So examples of transverse waves, we have water waves are transverse, waves due to a plucked string are transverse, light waves are transverse, and all electromagnetic waves, as we saw in the electromagnetic spectrum, they are all transverse waves. So if you look at longitudinal waves, for them, they are waves in which the displacement of the particles is parallel the direction of travel of the wave. So meaning that the wave will be displaced in the same direction in which the wave is traveling. So for example, if you look at this diagram, waves which show this kind of motion are what you call longitudinal waves. So longitudinal waves are characterized by what we call compressions and what we call rarefactions. Compressions and rarefactions. So compressions, these are positions of high particle density. You can see they are high particle densities. Positions here, or the vibration patterns are close to each other. In rarefactions, the patterns are far away from each other or separated by some larger distances as compared to the compressions. So examples of longitudinal waves, we have the sound waves, they are longitudinal, and also the waves due to a compressed spring are also longitudinal. So if we are to differentiate between the transverse and the longitudinal waves, the transverse waves, the particles vibrate at right angles to the direction of travel, or they vibrate perpendicular to the direction of travel, whereas for longitudinal waves, the particles vibrate along the direction of travel or parallel, or we can also use the word parallel, the direction of travel of the wave. Then transverse waves are represented by crests and troughs, whereas longitudinal waves are represented by compressions and rarefactions. So basically, that's it for now for our introduction. So in our next chapter, in our next episode, we shall look at the components of the wave, and we shall know all the various terms of the wave. So subscribe to our channel, share our lessons with your friends, comment to enjoy all our lessons.